Hello, everyone. Welcome back to a new Keep Looking Up. It's been a while, and we're so excited to join you guys again this evening as we talk all things Mars. Um, I'm Tiffany Woolbrick with the Word Beecher Planetarium, and joining me this evening is our engineer, Kurt Spivey.
Welcome back, Tiffany.
Yes, thank you, Kurt. For those of you who don't know, I had a baby, a quarantine baby, and it was on maternity leave. So I'm back and excited to be back and to see you all. Also joining us is our student workers, Eleni Hunsick.
Hello.
And Nishan Adhikari.
Hello.
So we wanted to give you guys just a quick update before we get started with our show this evening, which will be all things Mars. It's going to be really exciting. If you have any questions or comments, please let us know in the chat. We'll be monitoring that on Facebook. And let us know what your favorite thing is about Mars. It's such a cool planet, and I'd love to hear what your favorite facts are about Mars. I won't tell you mine because Leanie's going to talk about it later. But a quick update about the planetarium. We do remain closed to the public right now, but the university is taking steps to open for in-person classes in the fall, and that's sort of the timeline of what we're thinking of as well. We're talking right now about making plans on how to reopen to the public and doing that safely. So we're ready to be back just as much as you are. So stay tuned, and in the meantime, we'll meet you here virtually. We have a lot of great shows planned, and we'll keep seeing you on social media till then. We're going to get started with a current look at the nighttime sky. It's been a while, so I'm going to share my screen here and get started with an update. It's changed quite a bit since our last Keep Looking Up show. I have this really great open source software called Stellarium. And that's you can download this for free and play around with it yourself if you'd like. It's stellarium.org. I've even bought their app for my phone and reference it all the time. It's a really wonderful software that's allowing us to see the nighttime sky together on our screen. This is the current nighttime sky at about 9 o'clock tonight, facing the southwest part of the sky. And wow, this is such a beautiful time to look at the stars. What we're seeing here, these really bright stars in this area of the sky is commonly referred to as our wintertime sky because it's best seen during the wintertime. But if you factor in Ohio weather, especially, or winter weather in general, now might be one of the best times of year to see it, even though it's not up for very long. We have clearer nights. Hopefully they're getting warmer as we get closer and closer to spring. So if you do have a clear night, go out and check out the winter sky because we're losing it. It's in the western sky. It's going to start to set by midnight or so. It's going to be gone. But one interesting thing over here in the western sky is the planet Mars. We'll be talking all about Mars tonight, and it is in our evening sky shortly after the sun sets. It is also very close to a popular cluster of stars called the Pleiades. This is it's also sometimes nicknamed the Seven Sisters because if you have really, really good eyes and very, very dark skies, you might be able to count 7 stars there, but it's actually a collection of several hundred or possibly a couple thousand stars in what we call an open cluster. So they're actually gravitationally bound. They're physically close together in space. And they're in the constellation Taurus the Bull. So Mars being very close to the Pleiades is unusual. Kurt, you know when this last happened. It's been a while.
I don't know when it last happened, but it is as close to the Pleiades as it will be until 2038.
Okay, thank you. Yes, so it's sometimes when planets are really, really close to other objects, we call that a conjunction. And so that's just kind of uncommon for Mars to be that close to the Pleiades. And it's really, really easy to find that planet right now in our sky. So this is Taurus the bull, as I mentioned. Here's some artwork to kind of better visualize it. We have the big horns shooting up this way and the body. And the Pleiades are traditionally drawn on the back of the bull. We have another constellation in our sky right next to it that's a very famous constellation. You will probably recognize the 3 bright stars in a line that make his belt. This is Orion, the hunter. And let's see if we can see the art there. You can see it a little better. There's a long story about why that's a lion's pelt. We don't have time to get into that tonight, but that might be a good topic for further discussion on another video. But Orion and Taurus are locked in battle. That has to do with some Greek mythology stories behind the constellations. And Orion is really easy to spot in the sky. It has very, very bright stars. This is probably one of my favorite stars in the sky, Betelgeuse. It's a red supergiant star that mysteriously, gosh, is that a year and a half ago now? Got very dim out of nowhere. And that was exciting because we know that this star is at the end of its life. And we also know that it's large enough that it would likely go supernova, which would be this big bright thing in our sky. It would be really cool. Probably not going to happen in our lifetime though. And then this really, really bright star at his foot, Rigel, is very blue. Betelgeuse is very red, and they physically look red in the sky. So Betelgeuse looks red like Mars in the sky. And so does this star Aldebaran, which is the eye of Taurus. So we have 3 red, bright red objects in our sky, almost in a line tonight. That's pretty cool. Orion was a famous hunter, and so he had a famous hunting dog that followed alongside him. This is Canis Major, the big dog. And on it, depicted on its collar here, is the star Sirius, which is seriously the brightest star in the night sky. Bad joke, but helps you remember. So Sirius, #1 brightest star in our entire nighttime sky, and it's front and center in our southwestern sky tonight at 9 o'clock. Definitely go out and check this out if you don't have clouds overhead. Again, just one of my favorite areas of the night sky. Now, we all know that spring is coming. Warmer weather is coming. We've seen a hint of that. So I'm going to move forward, or move towards our eastern sky, because rising in our eastern sky, we have the constellation Leo, the lion. And Leo is the centerpiece of the springtime sky. So when you see Leo in the sky, that brings out warmer weather. That's a promise that warmer weather is coming. I love to see Leo in the sky. It's a beautiful constellation, but also it means better weather is on its way. I'm going to move forward in time now. So right now, again, this is about 9. I guess that was about 9:30. But we're going to move forward to about 6 a.m., just before the sun comes up in the morning. We have something pretty cool over in the eastern sky. I don't want to go too fast there. Okay, so our moon rises pretty late tonight, and you'll see right before the sun comes up. I'm going to go back because it's actually, you would not be able to see this at that point. It's going to be pretty low on your horizon, right as the sun is rising. We have 3 planets in a row, in a line right there: Mercury, Jupiter, and Saturn. And a couple days, the moon is slowly moving towards the sun, towards the phase we call new moon, when the moon is right next to the sun in our sky. So we're going to have this very thin crescent moon making a diamond shape with these planets in a few days here. I would say 1, 2, maybe 3 days. So take a look for that if you're a morning person or a really strong night owl, either way. Those are just a couple of interesting things that we can see in our sky right now. I didn't want to spend too long on our nighttime sky because we have a lot of really great things to talk about with Mars. I'm going to hand this over to Eleni here in a minute. Do we have any questions right now?
Not right now.
Okay.
Dr. Durrell has chimed in and is watching.
Oh, hi, Dr. Durrell. Good to have you. Eleni, whenever you're ready, you can share your screen.
Okay. Thank you, Tiffany. So, sorry, it's been a while since I've done this. Here we go. All right, so I am going to tell you all about past missions to Mars. First, I will start out with just some background on the planet Mars. If you regularly attend our shows, you probably already know that Mars, as well as a few other planets in the solar system, and as Tiffany just told you, are visible without a telescope in the night sky. And again, Tiffany just showed you this, but here is a really cool picture that's just from the other night, I think last night or the night before, of Mars over here next to the Pleiades cluster. So when ancient civilizations looked at the stars and made maps of the stars, they noticed that there were 5 objects other than the sun and moon that didn't move in the same way the stars did. The ancient Greeks called these objects planetes, or planets, which means wanderers, since they appear to wander relative to the stars over several months. These objects were Mercury, Venus, Mars, Jupiter, and Saturn, the 5 planets that are visible from Earth without a telescope. Hundreds of years ago, astronomers and mathematicians tracked these objects very closely and were able to determine that they are within the solar system. This was very exciting as it encouraged people to start thinking about what these planets might look like up close. So astronomers started to prioritize the development of telescopes. So here is a picture of what Mars looks like through an 8-inch telescope. This is similar to what observers could see in the late 1800s. So we're already getting to a couple hundred years ago. Mars is still a very new place to us. As technology continued to develop, observations from several astronomers revealed that Mars has very interesting terrain, which continued to increase people's curiosity about the planet. As scientists began developing the first missions to the moon in the early 1950s, some took things a step further and proposed exploration of other planets. In the early 60s, the first planetary missions were sent to Venus, as Venus is the nearest planet to Earth. However, Venus is exceptionally difficult to observe up close as it's covered in opaque clouds, and surface conditions such as the temperature and the pressure are so high that landers are destroyed within minutes of reaching its surface. But understandably, the focus quickly shifted to the second closest planet, Mars, because it's a little bit easier to explore. And for the remainder of our program tonight, Kurt and I will tell you all about Mars missions. So far, there have been 49 attempted missions to Mars, and I say attempted because getting to Mars is not easy. The first Mars missions were in the mid-60s, and about half of them have failed due to issues such as failure to launch, failure to orbit, failure to land, and lost communications. This is an image of the crash site of the European Space Agency's Schiaparelli lander from 2016. Due to complications with the onboard computer, the lander unexpectedly started spinning during its descent to Mars and crashed into the surface. This image was taken by the Mars Reconnaissance Orbiter, which Kurt will tell you a little more about later. But I do want to note that technology is improving. So while there have been a few failed Mars missions in the last couple decades, NASA hasn't lost any Mars missions in over 20 years, thanks to more precise technology and very careful planning. And because I won't have time to talk about all 49 attempted missions to Mars, I'm going to focus on NASA missions, specifically NASA missions that involve landers and rovers, because I think those are the most interesting. So first is the Pathfinder mission. In 1996, NASA created and launched a new type of lander that carried the first ever Mars rover called Sojourner. Both the lander and the rover carried tools to learn about Mars's atmosphere, climate, geology, and the composition of its rocks and soil. In 1997, Pathfinder entered the atmosphere of Mars, flowed by a parachute, and successfully landed by using a system of 24 airbags, which is what I'm showing you right now. But the next thing I want to show you is really cool. It's a 360 view of the landing site of Pathfinder. And I think I have to open this separately because it's a 360 video. I already have it pulled up. So let's just, yep. I'll make this full screen. So this is the landing site of Pathfinder. And here you can see Sojourner. If we look down, you can see the deflated airbags that I was just telling you about. And here's the landing site. So, So Pathfinder landed in a valley called Aris Vallis. And it's a shallow valley that was likely carved by flowing water about 3 billion years ago. This site was chosen because it was determined to be a relatively safe, flat place to land, and Sojourner would be able to analyze the wide variety of rocks that were deposited here during floods. These two small hills were discovered by Pathfinder, nicknamed Twin Peaks. They're both about 100 feet high. And as you can see, scientists also like to name different areas and rocks on Mars. So this is called the Rock Garden. This rock is named Barnacle Bill, and this rock is called Yogi. So analysis of Barnacle Bill here showed that this rock is very similar in composition to andesitic volcanic rocks found on Earth, which is a type of rock that forms when magma cools slowly beneath a planet's surface. This is a very important discovery as it implies that Mars was once geologically active and that different types of rocks form due to a rock cycle on Mars, similar to the rock cycle we have on Earth. And then over here, analysis of Yogi showed that it was a basaltic rock, another type of volcanic rock that forms when lava or magma cools very quickly. Basaltic rock makes up most of the volcanic rock on Earth. And this confirms that Mars was volcanically active in the past and confirms that large features that scientists have observed on Mars, including Olympus Mons, the tallest mountain in the solar system, were once active volcanoes. And then finally, over here in this area called the Rock Garden, Sojourner identified sand dunes that are similar to crescentic dunes seen on Earth, which are likely formed by gusts of wind. And finally, Sojourner found smooth rounded pebbles, among other things, that imply that stable flowing water existed on Mars at some point in the past. This was a particularly exciting discovery that many scientists were hoping for, because the only common requirement for all life on Earth is water, which implies that life may be able to exist on other planets, though this still cannot be confirmed or denied due to many other factors. Pathfinder was intended to last for no longer than a month, but it operated for 85 days, and obviously it made a lot of substantial discoveries. So back to the PowerPoint. The next rover I want to talk about is everyone's favorite pair of rovers, and I just dropped my keyboard. And these are Spirit and Opportunity. These two were sent to Mars as part of NASA's MER mission, which stands for the Mars Exploration Rover mission. In 2003 is when they were launched. They successfully landed at 2 different locations in 2004 using landing technology that was very similar to the technology used for Pathfinder. The main objective of the MER mission was inspired by Pathfinder's discoveries regarding liquid water existing on Mars in the past. The 2 rovers were going to analyze rocks and soil to learn about past water activity. So this is where Spirit landed. This is Gusev Crater, which was initially thought to be a dry lake bed. The first image is of the crater as it looks from space, and the second image is a picture taken by Spirit after it landed. After Spirit analyzed the rocks within the crater, this crater was actually determined to be probably an impact crater, but further analysis has shown that the rocks have been altered by small amounts of water, perhaps because of fog, or the crater may have been filled with liquid water for a very brief period of time, but then it became buried in dust or volcanic material. Spirit lasted for 25 times longer than it was supposed to, ultimately losing communication with Earth in 2010 after getting stuck in soil and getting too cold. But fortunately, Opportunity was extremely successful. Opportunity, nicknamed Oppie, landed in Meridiani Planum, a plain near Mars's equator. And here is a picture of that taken by Opportunity. And this crater is very interesting because it contains a rock called hematite. And hematite happens to be my favorite rock. So I have some here and I want to show it to you because it's really cool. So I'm going to stop sharing for 1 second. So this is hematite. It's very sparkly and it's very heavy because it is made up of iron, which iron is actually very abundant on Mars. That's why it looks red, and that's why it's called the red planet, because iron oxide is just rust. So Mars is very rusty. There's lots of iron, and I have a bigger piece of hematite here that also has some quartz embedded in it.
Yes, Eleni, you might want to say that's from Earth. Those aren't actually Mars.
Yeah, no, these are not from Mars. No, yeah, we do not have Mars rocks. These are Earth rocks. But I just wanted to show this to you because it's my favorite rock and it's really cool, and I'm excited that it also exists on Mars. So I'm going to share my screen back to the PowerPoint. Okay. So hematite, yes, those were Earth rocks, but it does also exist on Mars, and this is really significant because hematite often forms on Earth. It forms in hot springs or standing pools of water, and Opportunity wanted to determine if this was the case on Mars as well. So here, this image on the left is from Opportunity, and these little round rocks here. This is a very close-up image, so these are very small. That is hematite. These are little hematite concretions. They're nicknamed blueberries because they look like little blueberries. But they indicate that this crater that Opportunity landed in was once a watery environment. And this is just one example of the overwhelming evidence of past water on Mars that has been observed by Opportunity. And then this picture here on the right shows the capabilities of some of the tools that these two rovers were equipped with. This picture is also taken by Opportunity, and this shows how the abrasion tool was used to expose the interiors of rocks for analysis. This is a false color image just to show you the distinctions between the different types of minerals that were on the interior of the rock and the exterior of the rock. Opportunity continued to operate until 2018, when a large dust storm occurred on Mars and the rover began to hibernate. It was supposed to continue operations after the dust storm, but communications were lost, indicating some sort of failure or maybe that its solar panels were buried in dust. And the last transmission from Opportunity has been famously translated as, "My battery is low and it's getting dark," which is kind of sad because scientists we were all very attached to Opportunity. It made a lot of really cool discoveries, but still Opportunity was an extremely successful mission and it lasted for so much longer than expected. So next in 2011, another Mars mission was launched called the Mars Science Laboratory, or MSL. The Curiosity rover was part of this mission and it landed on Mars in 2012. The method for landing this rover was different from previous missions. The spacecraft first descended into Mars's atmosphere using a parachute, and then it activated rockets that allowed it to hover and lowered Curiosity to the surface on a set of tethers. And then once the rover was on the ground, the tethers were cut and the spacecraft flew off to crash land a safe distance away so that it wouldn't hurt the rover. So the objectives of Curiosity were to investigate Mars's climate and geology, assess whether the selected field site ever had environmental conditions suitable for microbial life, and to learn about planetary habitability in preparation for human planetary exploration. So Curiosity landed in a flat area of a very large crater called Gale Crater, which was likely a past. And in this picture here, this is looking at the center of Gale Crater. This is an 18,000 foot tall mountain. And again, this picture is taken by Curiosity on Mars. This seems like a really big mountain compared to Earth mountains, but because Mars is really, really small and barely has an atmosphere, then the mountains there aren't really affected much by gravity and weathering, unlike mountains on Earth. So mountains on Earth, they get built up by geologic processes, and then they're worn down by erosion, storms, weather, and gravity actually pulls them back down. But on Mars, because Mars is so much smaller, its gravity is not as strong, and while Mars does have dust storms, it doesn't have the intense rainstorms or other massive weather events that would cause the mountains to erode. So Curiosity can also take selfies. A lot of people really enjoy this. There are so many pictures like this. They're really neat. But this is just so that Curiosity can take 360 panorama images. So it can spin all the way around and take pictures of the Mars landscape all around it. And as you can see here, Curiosity is really, really big. It's about the size of a car, and it has a lot of scientific instruments. Curiosity has used these instruments to make a lot of discoveries. Thanks to the rover, we now know that Gale Crater contained lakes and flowing water for a period of at least 100 million years, perhaps even longer. And again, this was a long time ago, probably about 3 billion years ago. We don't think that liquid water has flowed on Mars in recent times. But Curiosity also determined that Mars at one point had the right chemistry for microbial life to survive. We don't know if there was microbial life. There's no evidence of that yet, but we do know that the chemistry was right for it, the same way that it is on Earth. And additionally, Curiosity found that methane is being added to the Martian atmosphere, which is probably due to chemical reactions between rocks and water. So we're pretty certain that there is still water somewhere on Mars. We know that Mars has ice caps, even though those are mostly frozen carbon dioxide. There's also some water in there. But the addition of methane to the atmosphere is also interesting because on Earth, that's created by life. Now, again, we don't know that there's life on Mars. It would be really, really difficult for life to survive on Mars, but it does encourage us to keep exploring and keep learning about Mars. And finally, Curiosity gathered important information about the types of harmful radiation that are present on Mars. And this information will help with the development of and safety of future manned Mars missions. And the Curiosity rover is still on Mars today. It's still exploring, it's still active. Here's one of the most recent pictures that it took, and it's continuing to learn about Mars's past, and it's going to continue to collect information that will help us prepare for future Mars missions. So before we go on, does anybody have any questions?
Yes, Jim has a question for you, Eleni. Is there an oxidizer in Mars's atmosphere that causes the red rust, or was this created when there was running water on Mars?
That is a very good question. Does anyone else know the answer to this? I think I know the answer, but I don't want to give the wrong answer, so I'm going to let someone else try and answer it.
Well, you're more of a geologist than I am, but
Okay.
From what I understand, because the atmosphere is carbon dioxide, there's enough oxygen in the atmosphere to oxidize the iron, and most of Mars's oxygen is now bound up with the iron, from what I understand.
Yeah, I agree. I'm pretty sure most of the oxidization occurred a long time ago, but yeah, they're definitely, that oxygen is definitely still present. It's just bound with carbon as carbon dioxide. So there's no oxygen in Mars's atmosphere right now. or not a significant amount at least.
I'll get to
Are there
that.
any other questions? Okay, if there are no other questions, then I will hand it over to Kurt to talk about
Can you
current Mars missions.
so we have a question. Can you show us a view of where each of the rovers landed relative to each other?
I
Were they near each
attached a
other?
map to that comment. I couldn't find one that had Perseverance marked that well on it, but let me see if I can open that, and I will share that before I go on to mine. 1 second here. Okay, so let me move this over here. And then I gotta close those. And then I'm going to share screen. And I'm gonna
Oh,
share
yeah,
that.
that's a good map.
Yeah, where did I put that? I've lost it. Hold
Are
on
you
one
wanting to
second.
share the same map? Because I can just share it real quick.
Yeah, you can
Okay.
probably do it faster than I can.
Okay. So this is a false color image to show elevation on Mars.
Mhm.
And it's you can imagine if you were to peel the planet like an orange and lay the peeling flat, that's kind of what you're seeing here. It's like a flattened version of the surface of Mars. And here are the different locations. Yeah, you're right. I don't they haven't updated it with Percy.
Well,
But
it says Mars 2020. That's where Percy is.
oh, yeah, you're right. That is.
Yep. That's why I chose this particular one. You'll notice a couple of missions that Eleni didn't talk about. Viking 1 and Viking 2 landed on Mars in 1976. They were the first missions ever to land on another planet. They were not rovers, though. Eleni concentrated on rovers. They were just landers. They landed, took pictures where they were, and eventually ran out of power. If you look to the upper left, you will see Mars Phoenix, which was specifically designed to study the polar ice cap of Mars, but because it was at such a high altitude, it was not a rover either. It did not last. I think it was only about a year it lasted. We do have another lander that is not a rover on the surface right now called InSight. You see it over there on the right near where Curiosity is. And it's still working. What it tried to do was it had a drill on it and it was going to bore down into the ground, and they never could get the drill to go in. The dirt just kept filling up the hole and they couldn't drill down. But it's studying geology and seismic activity on Mars right now. And then the ones in red are from other countries. And I'm going to get to a couple of those anyway as we go through with my talk.
All right, great question. Thank you. Go ahead, Kurt.
Okay, well, with that being said, we are going to go on to the current Mars missions. I know Curiosity and InSight are current. There are also plenty of orbiters in orbit. It's getting rather crowded around Mars as far as orbiters go from different countries. But we're going to concentrate on the ones that are the new arrivals, the new members of the fleet of Mars missions. And so I am going to share this. And that's optimized, okay. And the first one we're going to talk about is a newcomer to the world of interplanetary study, and that's the United Arab Emirates. They launched a mission called HOPE. It launched on July 19th of last year. Let me get over here so I can click on that. That's what HOPE looks like as the United Emirates we're getting it ready. The UAE, as they are referred to, the country, is new to the space game. They only have had a space agency since 2014. And before this mission, they have put several satellites in orbit around Earth, but this is their first time out of Earth's orbit. And it was successful. They took off from Japan on a Japanese rocket on July 19th, and it reached orbit around Mars on February 9th, few days ahead of Perseverance. No mission is going to go down to the surface. It's going to study Mars's atmosphere and climate. But our first new picture of Mars came from Hope, and this was Hope's first picture of Mars once it reached orbit. So we're going to be hearing more from that mission coming up too. But just the day after that one arrived, the People's Republic of China also have a very ambitious Mars mission coming up. They have a couple of orbiters that have reached Mars ahead, but this is Tianwen-1. It launched on July 23rd, and it reached orbit the day after Hope on February 10th. So it is in orbit right now. It is taking pictures as well. But if you look at that cone thing that's up at the very top of the spacecraft there, that's going to be a lander. So this is going to be an orbiter and lander. They sent them together to Mars. You'll notice this looks rather like Pathfinder and Sojourner did. This is their first attempt. They have not launched the lander yet. They're planning on doing that in May of 2021. And if you remember that map we were showing you before I started this PowerPoint, the landing spot for this rover is going to be somewhere between, about halfway actually, between where Viking 2 landed back in 1976 and where Perseverance landed, which we're going to get to in just a minute. But that's going to study geology of the surface of Mars. And it is, let me back up a slide. It is got a base that's going to be the relay station up to the satellite. And the rover will go around and study the rocks and geology. But this is very ambitious. And as Eleni said, it is amazing that all three of the missions that went off were successful. There is actually about a 1/3 success rate when it comes to sending stuff to Mars. There have been a lot of failures over the years. NASA has a very good record, but a lot of other places do not. So it's really cool that all three are working. But now we're going to move on to Perseverance. And if you remember the pictures that Eleni showed you of Curiosity, you'll notice the Perseverance rover looks very, very similar to the Curiosity rover. That's because if it ain't broke, don't fix it. You'll notice that neither of these rovers rely on solar panels like Spirit and Opportunity did. They actually have nuclear reactors on board to provide their power, which also keeps their instruments warm too with the radiation, by the way. But even though it looks an awful lot like Curiosity did, this one just launched last year in 2020. Curiosity launched in 2012. Think about your cell phone, of what your cell phone is like today compared to what it was like in 2012. And the technology upgrade for these missions is very similar in what this is ambitious mission is going to do. And just like with Curiosity, Perseverance is laying the groundwork for future manned missions to the red planet with a couple of things. First off, its arm here is not only going to study the samples. Curiosity had a drill on that could bore into rocks and spectrometer. This has that too. But the other thing that is so cool that Perseverance is going to be doing is it's actually going to collect samples of Mars, and it's going to store them on the spacecraft. And in about 4 or 5 years, NASA is going to have a joint mission with the European Space Agency that is going to send another spacecraft to Mars. It's going to land next to Perseverance. It's going to collect those samples, and then it's going to bring them back to Earth. It'll be the first time we'll ever return samples from another planet. We have had little bits of Mars here on Earth. Those happen when pieces of Mars got blown off into space, when something thwacked into it, and they traveled millions of years and they landed on Earth millions of years later. The most famous is the famous asteroid that landed in the Antarctica, ALH some long number, that caused a stir back in the 90s that everybody thought we had discovered life on Mars in this meteor, but that was contaminated by the Earth's atmosphere, and I think that's what ended up doing it. These are going to be pristine, just like when the astronauts brought the rocks back from the moon for the first time. This is going to be a first for this. Where Perseverance landed is an area known as the Jezero crater. And if you take an overhead view of the Jezero crater, it looks very much like the Mississippi River Delta where it comes out at New Orleans, except without the water now. But this is a very likely spot that an ancient Martian river flowed into a Martian sea. So this is a very likely spot to find signs of past life on Mars. And if there's any chance that there is still water on Mars, this is a really good spot down underneath the ground where water could be. And Perseverance is going to be looking for that. As I said, it is preparing for future human missions to Mars as well. And one of the things that's going to be doing that is right here. I don't know if you can see that. It's right by the front wheel in this artist rendition of Perseverance I have up here. The piece of equipment is called Moxie, and I just found out last week that part of it was designed by 3D manufacturers right here in the Mahoning Valley, designed parts of Moxie. And what Moxie is doing is trying to take the carbon dioxide. Mars does have a very thin carbon dioxide atmosphere, but carbon dioxide is 1 part carbon, 2 parts oxygen. So Moxie is trying to take that carbon dioxide, split it apart, and make pure oxygen out of Mars's atmosphere. If that works, and they can figure out how to do that, astronauts that go to Mars will be able to have backpacks that will do this, so they don't have to carry big oxygen tanks around them, and habitats on Mars can convert oxygen out of the atmosphere too without relying on supplemental oxygen, which would be way cool. The other really cool thing that Perseverance has on board is a test vehicle. It is called Insight. And it is a little tiny helicopter. Basically, we're going to fly a drone on Mars, or try to anyway. It's not very big. It has carbon fiber helicopter blades on it, 2 sets of them. The atmosphere is so thin, they're not sure they'll be able to get lift with Insight. Perseverance has not deployed this yet. They're not planning to until around May or so. The reason for that is Insight has 6 lithium-ion batteries on it. And while it has checked in and said it's healthy from the landing, right now its batteries are charging off of Perseverance power supply, and they're going to give a test flight. What they're going to do is they're going to find a likely spot to try this out. They're going to have Perseverance drive to it, set it down, and then pull off at a distance where it can film it. Then they're going to try to lift it off. If that mission works, they might try longer flights with it too. But if that works, it will greatly expand the distance we can explore Mars. If future missions have these little helicopters on them, we'll be able to travel further over the surface and see more stuff up close than we can with the orbiters. Now, just to show you, NASA does get their geek on with this particular mission. Here is the parachute that landed Perseverance on Mars. And people looked at this and realized that does not look like it's just some sort of random pattern on the parachute. And as a matter of fact, if you look over my shoulder, you can see Matt Damon sitting here. If you have seen the movie The Martian, the way he ended up talking with Earth eventually was using a computer called ASCII. And people realized they put ASCII code on the parachute, and it spells out "Dare Mighty Things" on the parachute, and then around the very outside is the longitude and latitude of the JPL lab in Pasadena, California. So the JPL people got their geek on when they designed the parachute for Perseverance. JPL is the one that did the main design and building of Perseverance. That they didn't stop there though. One nice lady scientist had a family portrait on her SUV and decided the Perseverance should have that too. So she put a family portrait on Perseverance. You can look here, you can see from left to right, there's Pathfinder, Sojourner, Spirit, Opportunity, Curiosity, Perseverance, and they even put Insight on there too. So it has its own little family gallery on, just like you have on your SUV. Now, this was the very first panorama taken from, and one of the main innovations, and just like with your phone, you know how much better your camera is on your phone today than it was back in 2012. And this was the first high-res panorama of Mars and the Jezero crater taken by the Perseverance mission last week. And it's much higher quality. The reason it looks so distorted is this is actually a 360. The one side of Perseus ends here and starts over here. So you can see all of the Perseverance rover there at the bottom, but that shows you the area it laid in, and it landed spot on where they wanted it to. Now, another thing they'll be able to do is take very high resolution pictures as well. This was the very first high resolution picture from the Mastcam, the very tall camera on Mars, and you can see the detail they can get. This is a zoom shot of the edge of the Jezero crater a long distance away. Another feature that this Mastcam has is there are two cameras on that. They'll eventually be able to take stereoscopic pictures and make the pictures appear 3D, and we'll start be getting some of those soon too. The latest thing with the Mars rover, though, just yesterday, they took it for its first test drive. They drove it ahead about 2 meters over about 20 minutes. They turned it around and they drove it back, and then they took pictures of the path that it drove, and they drove it in a circle, make sure it's all set to go. So it's not going to be too much longer now until Perseverance starts exploring the Jezero crater and getting on with its science mission. Now, Curiosity was originally scheduled to last 5 years. We're already up to 9, and it's still going absolutely fine right now. We're expecting the same thing out of Perseverance. Perseverance's mission officially ends when that next mission arrives to take the samples back to Earth. But if it's working, they're going to keep running it just like they did Opportunity. So our age of exploring Mars is going to start really soon. Now, as I said, they really got their geek on when they put this mission together. And Eleni briefly explained to you how Curiosity got down to the surface. Well, they referred to that time of Curiosity landing on the surface as the 7 minutes of terror, because operators here on Earth, it was too much of a time lag between the signal and the rover landing on Mars for anybody on Earth to do anything. They just had to sit back and chew their nails until they could figure out if this thing actually landed as if it was supposed to. Well, they took some of the guesswork out of it this time using the Green Bank telescope in West Virginia and the Mars Reconnaissance Orbiter, which has been orbiting Mars since 2006. It's not only taking high-resolution pictures of the surface, but it's actually acting as a relay satellite for all these rovers on the surface. It's basically kind of like a communication satellite in orbit around Earth. Mars Reconnaissance Orbiter is serving that function above Mars now, and has fundamentally changed the way that we explore Mars by being able to perform this function for us. But for its landing, we were getting, with a little bit of a delay, but in real time, exactly what happened. And it also had navigation cameras on, so as the rocket lowered it to the surface, they put it right where they wanted to. But one nice geeky thing that they did was they actually added what NASA referred to as off-the-shelf cameras to the mission. And to me, that says GoPro. They probably stuck a bunch of GoPros on here, and they also stuck a microphone on the spacecraft as well. So after the fact, NASA was able to take the actual landing from the day that we watched and cheered about and matched it up with the video that came from Perseverance with the landing. So I am going to show you, it's not the full 7 minutes of terror, it's edited down a bit for time, but this is straight from NASA off of YouTube. I give you the Perseverance rover's descent and touchdown on Mars.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Applicant indicates chute deployed.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
TRN safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
So there you go. That is, I'll bring my video back. So there you go. That is the Mars Perseverance ready for a great time at Mars. So we're looking forward to great things from this mission and the other two that just arrived at Mars as well. Back to you, Tiffany. Any questions?
That landing, the Perseverance landing, was so exciting. It's so exciting to watch the video. It was really cool to watch it live too. I'm not seeing any questions, but if you have any questions or comments, please let us know as we wrap up here. Thank you guys for joining us. We will be returning with Keep Looking Up. We're doing them every other Saturday. So our next one will be March 20th, and that will be focusing on women in STEM, so women in science. And we will also be resuming some of our other show segments, online segments like our Explore Science, where we do science experiments that you could do at home with your family or your kids. We do let's see, we'll have some news updates. We'll bring Life of a Scientist back, where we highlight the life of certain scientists. Oh, Starry Storytime has already started. We had one earlier this week with me and my new baby. So check
who
it out.
is named Leon, and we just saw Leo the Lions. I just
Yeah.
wanted to point that out. So
Yeah. So he's my little lion. You could check him out in our new Starry Story Time. And then we are also bringing back we're also starting a brand new segment called Cosmic Conversations. It's going to be a live show like this on Facebook Live. We're thinking Monday evenings, probably around 7 o'clock. And we are just going to spend maybe 5 to 15 minutes, a short amount of time, focusing on one object or constellation or something up in the sky that you can see. So we haven't decided on our first object yet, but say it's Leo, the constellation Leo, then we'll talk about the constellation, some of the lore, the history and the stories that are told around that constellation. We might mention some interesting astronomical things that you could see in it if you had a telescope, where to find it, even if you don't have a telescope, where to find it in your nighttime sky. And then you guys are welcome to come and share your information, share your knowledge on that topic, on Leo, for example, or ask any questions or anything like that. I think it'll be fun. I'm excited to have conversations with you guys about all the wonderful things in the sky. And I think that's it, right, Kurt? I'm not forgetting anything.
I was muted. There we go. I think that's it. I think you mentioned we're going to do Explore Science as well.
Yes.
So we're going to bring back a lot of the things you've seen before. Our schedule is going to be about one show a week plus our Keep Looking Up shows. So we hope this will help whet your appetite, and we are chomping at the bit to get back under the dome ourselves.
Yes, we hope to see you under the dome soon, but until then, we look forward to seeing you here. Have a good night, everyone, and remember to keep looking up.